Welcome to FEED, a project, or better, an integrated approach, which combines tools and techniques in design and food chemistry for experimenting new sustainable products in cosmetic field. Recent studies and reports on companies involved in cosmetic sector demonstrate a steady growth in turnover, both nationally and internationally, with import and export flows extended globally. But cosmetic market is broadly changed, and in its heterogeneous and geographically diffuse dimension, with a very high European share, made in Italy is characterized by companies that I invest in creativity, I invest in innovation, and I implement design oriented strategies. This is in line with a sustainable production, traceability of ingredients, which are both from the growing demand for eco-friendly cosmetics. And the sustainability is in the design, is also in the chemistry of cosmetic products. And it requires a careful analysis of the entire production chain. Sustainability, in other words, has to be a distinctive identity feature. Ingredients, processes, packaging materials, and all the strategies are involved in the life cycle assessment of cosmetic products have to be defined with a sustainable and ethical approach. The importance of supply chains, from ingredients to chemical formulation, from extraction processes to manufacturing of cosmetic lines, from the distribution strategies to the product transmission, are the main part of a new cosmetics product's success. In this context, there is FEED. There is our multidisciplinary approach, which is the driving force for the development of a new concept in cosmetics. In fact, according to eco-oriented principles and based on agri-food sector analysis, biosustainable active ingredients could be used for a new skincare line. Design food chemistry at a table to convey a new concept of wellness and body care. Kitchen waste recycling for reducing their environmental impact, for obtaining through a well-integrated skills and competencies, new sustainable and fully natural cosmetic products, with the aim to introduce new behavior in the daily life, with the aim to transfer the awareness about environmental effects related to reduction, repurpose and recycling of food waste. Applying topically antioxidants could be an efficient strategy to enrich the endogenous skin system, thus preventing oxidative stress-related disorders and diseases. But who are the main actors in FEED project? They are natural molecules, and in particular phenol and polyphenol compounds, which are known to be able to counteract, to slow down free radical formation and propagation. In FEED, the recovery of these substances from alternative but rich sources as kitchen waste and their employment in antioxidant products for face aim at protecting skin from exogenous radicals, as well as at preventing delaying epidermal cells aging. Feed is articulated in three main products. The first is a soap scrub, enriched with exhausted coffee powder for a cleansing and exfoliating treatment. Then there is a peel-off mask with the extract obtained from broccoli waste for revitalizing and soothing treatment. Finally, a cream with orange peel extract with moisturizing and elasticizing effects. Cosmetic references were realized at the food chemistry lab of the University of Campania Luigi Vanvitelli with the idea to create a kit lasting about a month in which each product is a phase of reconstituting and protective treatment from UV rays and polluting sources. Each product can also perform an anti-aging action. To this end, in the consciousness that kitchen food plant waste are very rich in sugars, minerals, organic acids, fibers, and mainly in bioactive compounds, exactly like their edible counterparts, three alcoholic extracts from orange peels, coffee grounds, and broccoli leaf stems were prepared using an eco-friendly alternative extraction process such as ultrasound accelerated maceration. Extracts obtained were chemically purified through the combination of ultra-high pressure liquid chromatography and high-resolution tandem mass spectrometry techniques. The extracts from orange, coffee, and broccoli waste were further tested in order to estimate their scavenging capacity against the PPH radical and ABTaz radical cation. Both the methods are based on the reduction of the radical probe in presence of antioxidant capable of donating an hydrogen atom or an electron. When radical scavenging efficacy was tested, it was observed that the three extracts exerted a dissimilar anti-radical effect against the two radical probes considered, albeit dose-dependent in all the cases. The most active extract is coffee ground extracts, which showed an activity comparable to that observed for Trolox, a synthetic analog of vitamin E with the well-known antioxidant capacity and commonly used as a reference compound. Thus, for establishing the new cosmetic references, the recovery and the reuse of bioactive polyphenols from kitchen plant waste was pivotal, as such molecules can exert cosmeceutical action, as they are good candidates to replace synthetic compounds with negative effects on health and environment. In particular, our data show that orange peels are mainly rich in flavones and glycosylated flavonols, differing in B and C rings oxidation degree and in their glyconic moiety, in its position, and in the glycoside bond type. Rutin appears to be the main component, followed by naringenin 7-O rutinoside and apigenin 6,8-DC glucoside. Glycosylated flavonoids characterize also broccoli waste extract. In particular, UHPLC-HRMAS analysis highlight the presence of flavonols. Flavonols such as quinferol, quercetin, and isoramnitin, mono and dihoglycosylated, in which the saccharide moiety is likely to consist in sulfurous or gentiobiose. In addition, the presence of camphorol and quercetin glycosides differently isolated was evidenced. Coffee grounds extract chemically differs from the previous ones due to the presence of phenolic acids instead of flavonoids. In particular, chlorogenic acids and caffeoylcyclimic acids were identified as constituents of the coffee grounds extract. Moreover, besides the presence of the more polar phenols and polyphenols, the content of fatty acids, saturated, mono or polyunsaturated, was detected in all the waste extract. Oleic acid and linoleic acid content is almost comparable in the three samples, whereas alpha-linolenic acid, which seems completely absent in coffee grounds, reaches the maximum content in broccoli waste. Palmitic acid was also detected in appreciable amounts in Brassica oleracea extract. The presence of fatty acids gives also added value to the investigated formulations. In fact, linoleic and alpha-linolenic acid have different functions in relation to skincare, such as the ability to affect metabolic processes in skin and to promote the activity of vitamins E and A. They are also used in anti-inflammatory cosmetic formulations, useful for treating skin lesions of dry skin or in the treatment of dermatitis and psoriasis. Cosmetic references were created, but also their packaging was investigated thanks to design tools aimed at realize ad hoc primary packaging for each formulation. Primary packaging that mainly consisted in tubes and thermosealed envelopes, whose choice lies in their extreme practicality and in the consistency of the products contains. Primary packaging elements that make up the treatment are placed into a secondary packaging, which consists into a box with a hinged lid and internal punch. Thus, feed project lies its foundation in agri-food byproducts, which are a real endless source of bioactive compounds whose reuse as alternative sources of low-cost and biosustainable active ingredients is desirable in nutraceutical as well as in cosmeceutical field. The collaborative methodology in feed is a prompt to convey a new concept of wellness and body care, for a new eco-oriented production of cosmetics in which food, winter waste are investigated for their cosmeceutical value and for the formulation of green cosmetic products.